G'day, welcome to this video. My name is Jay Desai, and I'm a solution engineer, solution architect for NGINX based in Melbourne, Australia. In this video, as the title suggests, we'll talk about NGINX and we'll focus on the load balancing side of things. What I intend to cover in the short video is, of course, load balancing. We'll look at the available methods with NGINX, and also we'll look at how you can configure session persistence with NGINX Plus. We'll also look at all these ways of load balancing from a technical point of view as well. So I'll jump into a VM and I'll show you how the functionality actually works. Let's get on with it. Before I jump on to the load balancing side of things, I'll just like to highlight the fact that NGINX is your extremely lightweight, performant, resilient, and easy to use all-in-one tool, which you can use as reverse proxy, load balancer, web server, API gateway, KIC, all in one. So you can run NGINX pretty much wherever you want. I've done a few videos where I've covered NGINX working as a reverse proxy, and I've done one for API gateway, I've done one for KIC. In today's video, we're going to focus on load balancing side of things. So with that, let's jump directly into load balancing. And the first question we get is, what exactly is load balancing? So if you go out and Google the definition of load balancing, it'll come back with these specific words. Load balancing is defined as the methodical and efficient distribution of network and application traffic across multiple servers in a server farm. A lot to digest. Anyways, in simple words, a load balancer is a load balancer which sits between the client and your backend service, and it receives requests from the client, and based on the incoming requests, it passes those requests on to upstream servers or instances which are capable of fulfilling that specific request. So that's the easy definition. In order to set up load balancing with NGINX, what you do is you define a group or a pool of servers that will handle all of these incoming client requests. This is managed by the proxy pass directive. So the proxy pass directive passes on these requests to the pool. Servers within the pool can be defined by a combination of their IP address and the port number, or a domain name, or even a Unix socket. For HTTP load balancing within NGINX, what we use is known as an upstream directive, and the upstream directive sits in the HTTP context. Now, if you're not familiar with the configuration and the context which sits within NGINX configuration file, I've done another video on that, which you can view, and I'll post a link to that in the bottom comments. And what you need to remember for this specific section is that the upstream directive sits within the HTTP context. In this example, what we see is our upstream directive indicates that it's got a server pool or an upstream name called backend service, and within it, there are two specific service or backend applications listed. The crucial part of the load balancing configuration is the proxy pass directive. So in this case, requests are forwarded or listened by the proxy pass directive of this specific server, and using the proxy pass directive, they're forwarded on to the backend service. NGINX selects appropriate server based on the load balancing method you have defined. In this specific example, no method has been defined, and thus NGINX uses the weighted round-robin algorithm as the default method. And talking about the default method of weighted round-robin, in this specific method, each request is distributed evenly across the pool of backend servers. Now, NGINX uses this mechanism of assigning a weight to each upstream or backend server. So in this specific scenario, the one in the middle, each one of these servers has the weight of 1, and it adds up to a total of 3 units. Therefore, the load is divided equally across these 3 endpoints. However, if you look at the example at the bottom, what I've done is I've manually defined the weight of each of those individual endpoints. And in this specific case, so if you look at the backend 1, or say the port 9001 application, I've defined a weight of 2 for it. And the way NGINX calculates how this weight works is that it adds the total number of weight or the total number of units across all the upstream instances. In this case, 5 plus 3 plus 2, so a total of 10 units. So 2 of the total 10 possible requests are routed to server number 1 or backend 1 or port 9001. 3 of the total 10 are routed to the 9002, and 5 of total 10 is routed to application number 3. These requests are distributed across these servers in a random fashion. Now, NGINX can also take a server out of the rotation if it fails a certain number of times. So the two key conditions for this are the maximum fails, or the max fails parameter, and the timeout for failure, or fail timeout parameter. So the max fails parameter specifies the number of consecutive failed connection attempts before a server is marked unavailable. And the fail timeout parameter specifies two specific things. One, the time limit for the consecutive failures, as well as the duration that the server is marked unavailable for. So in this example, if you look at backend 1 or the port 9001, it's got max fails of 10. So this server is allowed to fail 10 times within 90 seconds before it is marked unavailable. Once marked unavailable, NGINX does not send the server any new requests until the 90 seconds have passed. Listed here on the screen are the load balancing methods provided by NGINX and NGINX Plus, and the server weights we talked about in the previous slide can be applied across all these methods. So the very first method, the hash method, or the generic hash method, as we know it, uses the MD5 hash algorithm, and it's based on a key that you specify. So based on the key information, the client requests of a certain type are forwarded to the same server they originally connected to. This method is often used on the backend or behind a firewall, rather than being used on the front end requests. While this specific method can persist the session information, what you should note is that every time you add a new server or remove a new server from the pool, the hash keys most likely would be lost and the session information then becomes invalid. So that's a point to note there. The IP hash method, the second method, is very similar to the hash method. However, in that method, we explicitly say that you're going to utilize the client IP as the specific key. The least connection method, as the name suggests, sends a request to the server with the least amount of consecutive connections. The least time method selects the server with the lowest average response time and the least amount of active connections. So this algorithm's only available with NGINX Plus. That's a point to note. The last but not least, the random method passes requests to a randomly selected server. With the optional 2 parameter, NGINX randomly selects 2 servers based on the server weights, and then randomly selects one of those 2 based on the load balancing method you've selected and routes the request to that specific server. More details on these methods are available on the website, and I will ensure that the link is in the comments down below, so you can read up more about these methods. Now let's look at all these methods slightly in detail in terms of what the construct of the configuration looks like. So what we have here in this example, we're using the generic hash method and using the client request URI to build our hash key. So what I've specified here is the $value request URI. Essentially, it's a variable which NGINX captures the request URI. In other words, the client with a request URI of /example will always route to the same server, and the client with a different URI routes to a different server. So for example, /test would always go to, say, for example, backend 1, and /test2 would go to backend 2 or 3 or whatever it may be. So in this example here, we aren't showing any weights, but weights can be added to affect the initial server selection as well. So if changes occur in the upstream, the hash keys are recalculated. So as the point I mentioned earlier. What we have here in this example is the IP hash method, but in this case, it uses a very similar algorithm to the hash method what we used previously, but in this case, the key is already determined to be the client IP address. Now, this can be either IP4 or IP6 address. NGINX divides the whole IP address by the number of servers available. Although this guarantees that the request from the same client is sent to the same server, what you need to note in this specific example is that, for example, you've got a reverse proxy or a proxy kind of setup in front of these application servers. it could be possible that all your requests may be routed to the same backend server. So for example, if the requests originate from a proxy, your backend application server based on the load balancing method or the IP hash would think that every single request is coming from your reverse proxy, and it would be routed to the same server. So please make a note of that. What we have here in this example is we're using the least connections directive to control the load more fairly across all the backend servers. If there are multiple servers with the same number of connections, the weighted round-robin method would be applied to those servers. So if we specify a server weight, for example, as a server weight of 1 and server 2 has a server weight of 2, in this case, NGINX would say that server 2 can handle twice as many requests as server 1. So here's a unique example. So if server 1 has 5 active connections and server 2 has 8 active connections, NGINX will say that server 2 has least active connections because it is configured to have 2 times as many number of connections as server 1. Now, this is in a scenario where we've set up server 2 as weight 2 and server 1 as weight 1. So this is a weighted least connections configuration. However, I haven't got the weights in the slide here, which I've just noticed, but you get what I mean. The least time method. So in this example, what we are using is the least time directive with the header parameter in order to determine which server responds to the request the fastest. This is calculated value based on the average response time and also the active connection. So besides the header parameter, you can also use the least byte and in-flight parameters. So more details about this specific method is also available on our website, and I'll ensure that I include a link on the comments below. Now, this takes us to the session persistence side of things. Now, the easiest way to enable session persistence with NGINX is by using the sticky cookie. In this specific method, NGINX Plus adds a session cookie to the very first response from the upstream group, and it identifies or tags the server that sent the initial response. So the client's next request back to the server contains the cookie value, and NGINX Plus routes that specific request to the same upstream that responded to the very first request. So in this example, what you see out here, we're setting a sticky cookie with the name of SRV_ID, and we've defined a few optional parameters that of the expiry. In this case, it's 1 hour, the domain it applies to, and the path you want to consider. All the expire, the domain, and the path, they are optional parameters. Another way to configure session persistence is by using sticky route. In this case, NGINX Plus assigns a route to the client when it receives the first request. All subsequent requests then are compared to the route parameter of the server directive to identify the server which the request is proxied to. So the route information is taken either from a cookie or the request URI. And also there is a lot more details to this specific method, so I highly recommend that you go to the website and read more about it on how to configure this specific method. Similarly, sticky learn is a way you can configure NGINX Plus, where it finds the session identifiers by inspecting the requests and response. And once again, more details on this specific method is available on the website, and I'll point you to that. Some other things to note when you're considering load balancing with NGINX is that you also have a max connections parameter, which you can configure. So max connections parameter sets the maximum number of concurrent connections a server can handle. So here we've set the backend 1 to have max connections of 300. And with the max connection parameters, what you can also use in conjunction is the queue directive. And the queue directive, what it does, it places the unprocessed request in a queue where the upstream exceeds the maximum number of connection limits. So for example, if server 1 in this scenario was serving, say, for example, 400 active connections, 100 of them would be put in the queue. The timeout parameter here with the queue parameter controls how long the server waits before sending a 503 error to the clients in the queue. So guys, from a slideware perspective, when looking at the configurations, this is all I had. Now it's time to jump onto the demo. So let's go ahead and do that. beauty. So what I have here is a very, very, very simple setup. I've got a Ubuntu virtual machine over here. I've got a browser, which is from a local machine. So this is a VM running on my local desktop laptop. NGINX-V will give me the latest version of NGINX I've got running on this specific box. And what I have are a few configuration files already pre-created. So if I do a ls on here, you'd see that I've got a dashboard.conf, loadbalancer.conf, and a webserver.conf. So I've got a GitHub repo link to these files in the comments below as well. So let's go ahead and look at these configuration files. So the dashboard, stock standard, very simple. Dashboard, once again, is only available with NGINX Plus. You cannot configure or view a dashboard with NGINX open source. So dashboard running on port 8080. If I come out here, let me find the IP address of this specific box here. Where is it? Copy that here. Cancel that. Come on. Close that here, come back to the browser here, and okay, it is already serving a request. Now what we want to see is 8080, that's where we have our dashboard. Perfect. This is what we want to see at the moment. We have nothing configured. Let's have a look at the load balancer configuration. Excuse me. Do ls again. So these are the files we have. Before I jump in there, let me show you the local applications which I'm serving from this box here, and I'm serving it from the web.conf. So if I hit web.conf, you'd see that the configuration for my web server, so in this case, the same instance of NGINX, which is acting as a load balancer, is also acting as a web server and serving these 3 static files. In this case, it's serving 3 files on port 9001, 9002, and 9003. And what I've done to make things simple for some testing, which we'll do a bit later on, is I've inserted a header parameter called custom header, and for each of the applications I've inserted the name application 1, application 2, and application 3 respectively. So I'll show you when we'll use that feature. Now let's go ahead and look at the configuration we have for the load balancer. And this is my caplb.conf. So very, very simple load balancing file. I've got 3 upstream servers in my case. I'm serving them from a local machine, so localhost or 127.0.0.1. In your case, this could be all sitting on a different box, or they could all be sitting on 3 different VMs or 3 different endpoints. I'm listening to port 80 on my local machine, example.com, and setting proxies at header. All this information is essential to try and forward the request from the original requester to the actual backend. I've got the proxy pass directive here, pointing the traffic to backend service, which is over here. Why am I not seeing this service over here? Aha, that's because I don't have a zone directive defined. So let's go ahead and fix that. We need a zone directive over here. Save that, close that. Interesting. Let's try and see. Excuse me. Aha, there we go. We've got HTTP upstreams. Perfect. This is exactly what I was intending to see. Now you've got the 3 endpoints over here, and you can see the W, which is wait. And by default, we haven't defined a wait for it. So the wait is standard 1. I can manually go in here and change the wait from here as well. Edit selected server, selecting will help. And I can change the wait from here. I can set the max number of connections over here as well. And all this can be done from the dashboard. At this stage, it's not going to save anything. It's going to save it live. And the moment I reload the configuration, all that data is going to go, because I don't have a state file which I'm writing this to, but that's very simple. If you wanted to write and you wanted these changes to be persistent, you write them in a state file and they'll be saved. But we'll leave that as is for now and just come back to our configuration. So let's look at the config. Now, what it's doing right now is we have not defined a specific load balancing method. So by default, as I mentioned earlier, it's going via round robin. And if you look at the server weights, we haven't defined any weights over here. So the weight it takes by default is 1, 1, 1, and 1. So if I was to go to the IP and hit the box and hit refresh a few times, you will see, that the application 1, 2, and 3, the load is distributed evenly across those 3. So you can see out here, the number of requests routed to each endpoint is exactly equal. Now, at this stage, what I can do is I can apply server weights to these endpoints. I can make it persistent by making a change in the config, or I can directly do a change from the dashboard here itself. So for now, let me just go out and do a change in the dashboard itself. I'm going to edit the selected server, and I'm going to make it the weight of 5 and click save over here. Click OK. And now, from the slideware which I presented earlier, you would have noted that now I've defined the weight of 5 over here. So the way NGINX is going to determine where to route the request is by adding the total weight. So 5, 6, and 7. So 5 out of 7 requests would be routed to server 1, and only 1 and 1, or 1 request out of 7 and 1 request out of 7 would be routed to 2 and 3. So let's just go ahead and test it over here, and we should be seeing a lot of application server 1 when we hit refresh. And as you can see, most of the times it's application 1. And to try and test that out, what I'm going to do is run a simple. So I've got a terminal window open over here. Try and do a curl on the application server. And there you go. So this is where the custom header field is going to come into play. I'm going to try and run a simple test over here. If I was to simply curl on that endpoint, we'll get a lot of HTML information, and I'm just going to use I'm going to filter that out and just capture that specific header field. So for that, I'm going to run this command here. Try and run that, and there we go. So application 1, run that again, and most of the time the result should be application 1. So out of 7, 5 times it should go to application 1, and only 1 and 1 should be application 2 and 3. So it's quite evident over here. Let me just go ahead and run this in a loop so that we can see the changes happening live. So do this here, and I'll also include the script in the comments below. So there you go. Now it's running in a while loop, application 1, 1, 1, 2, 1, 3, 1. And as you can see, more weighting on application 1. So I can come out here and change this on the fly. We'll make this 1. Save it and go OK. And now you'd be able to see that it's already changed. You're going 1, 2, 3, 1, 2, 3, 1, 2, 3, a lot more. And the requests now are being routed equally. So 34, 12, 12, 35, 13, 13. Perfect. So we've seen how the weight across these endpoints work. Now, what we want to try and see is a couple of algorithms. So let's look at the hash, excuse me, based on the request URI. So for that, I'm just going to copy this over here, come out here, and insert a simple change over here where I'm going to insert hash based on request URI. Save that here, close that here. So do NGINX-S reload. So it's reloaded the traffic over here. And now you can see the curl requests out here. Based on the request URI, a lot of this information is routed just to application 3 because it's only going to the slash location. So if I come back out here, hit refresh a couple of times, you'd see that because it's selected application 3 and the request is going just to the slash, most of these requests would be served by application 3 over here because that's what it selected at the start. Same over here and same over here. Let's try the IP hash method where it routes a request based on the client's IP address. So let's test that out. So I'm just going to come here, comment this out here, IP hash. Save that, close that. Cd nginx-s reload. And now suddenly you've seen it's gone from 3 to 1. The new, excuse me, the new algorithm has been applied, and now the application once picked up that specific request because it's associated application 1 with the IP address which it's requesting from. If I come out here and hit refresh a few times, my IP is routed to application 1 at the backend. So you can see that it's same over here because it's running from the same machine, same IP. So it is being served by the same backend application server, which is exactly what we want, and that is exactly what we have configured. Now let's try out the least connections method. However, in our case, it's not going to work very well. We can just show it to you working, but because I'm just running it on a local machine, I'm not going to really have a production-like workload or anything. So you can just see that request would still be routed to all 3 servers anyway, because the other 2 servers, I'm not really going to have any load on them. So let me save that here. So nginx-s reload. Come out here, hit refresh a few times. There we go. 1, 2, 3, 1, 2, 3, 1, 2, 3. Perfect. So it's intermittently changing between 1, 2, and 3 based on how the requests are being routed. Mind you, I've also got another terminal window running or firing of requests on the same backend. So if I come to the dashboard, overall, what you'd see is the requests are still spread very evenly, even in the least connections method, because we don't really have any other performance test or real load of traffic hitting these endpoints. Awesome. So now this takes us to the example of showing how session persistence work. And the example we'll look at is the sticky cookie example. So let's look at that. Come back to our load balancer configuration. Look at this over here. Comment that out. And the directive we use for that is sticky cookie. Out here, hit this. So we're doing sticky cookie. So ID, let's just call it something cool. What do we call it? We'll call it LB underscore example. So this is the name of the cookie, LB example, and it expires in 1, excuse me, expires in 1 hour. Perfect. Let me save that here. Let me close that there. NGINX-s reload. You always run NGINX-t before, but I am a cowboy and I'm running this in my local dev environment. So if you're running it in production, please run NGINX-t before you go out and push the change out. Perfect. We push the change out, and now let's go out and make a request. So now this request is only, so this in the bottom over here, because it's coming from curl, there is no way that can actually store a session cookie. So that request is being routed to all the servers at the backend. So 1, 2, and 3, because it's coming from curl. However, the request coming from a browser, you can see that is being routed to the same upstream server. Let me come in here, go to developer tools and see where is that cookie? Cookie magic. Refresh here. This is the request, and beauty. There is the set cookie, and we call it LB underscore example, and there is the cookie, and it expires Friday. It's given it a time. So we set a time of expiry in 1 hour, and there it is in all its glory. Beauty. That's exactly what we wanted to set. So perfect. So the sticky cookie works for us using this example. Perfect, guys. So look, in terms of showcasing an example and live configuration, this is where I'm going to stop. I think this is enough to give you guys a hands-on look and feel of how load balancing works with NGINX. So give it a shot in your dev environments. Any questions, reach out to me on j.desai@f5.com. But it's been a pleasure. Until next time, have a good one.